Linear systems. Our objectives: solve linear systems of equations in 3 or fewer variables, categorize systems as independent, dependent, or inconsistent. You've likely seen systems of equations in 2 variables before, and those equations represent lines. The intersection of those lines would be the solution for the system. When we have systems of equations in 3 variables, it might look like this. We have a nice set of 3 equations, 3 variables. This is also called a 3 by 3 system. These 3 variable graphs occur in 3-dimensional space instead of on the xy plane. In 3 space, each equation is a plane, and the solution is where all 3 planes meet. Now, systems that have a single solution will have an ordered triple x, y, z solution. Graphically, this defines a point that is the intersection of 3 planes in space. We say this system is consistent and independent. Systems that have an infinite number of solutions are those which result in an expression that is always true, such as 0 equals 0. Graphically, an infinite number of solutions represents a line where the planes meet, or a coincident plane that is the intersection of 3 planes in space. We say this system is dependent. Systems that have no solution are those that result in a statement that is a contradiction, such as 3 equals 0. Graphically, a system with no solution is represented by 3 planes with no point in common. We say this system is inconsistent. To solve a system with 3 variables and 3 equations, we will look at elimination and substitution methods. First, we'll look at the elimination method, also called elimination by addition, on a 2 by 2 system. Let's start out with elimination in just 2 variables and solve this system. Now, I had mentioned that this is also called elimination by addition. That's because of the way we use the ability to add these equations. Now, I'm going to pick these 2 coefficients to try and make them the opposites of each other. They're already opposite in sign. So what I'll do is I'll take this equation and multiply it by 5 to get 10x minus 20y equals 50. This equation I will multiply by 2, and this gives me a negative 10x plus 10y equals negative 20. What I want to do is add these 2 equations together. When I add on my x's, those x values go away. My negative 20y plus 10y is going to be negative 10y, and 50 plus a negative 20 is 30. Dividing by negative 10 then, I get a negative 3. So normally you might think we were finished, except that I have my y, I still need to get my x. So now that we have the y, we can pick that up and use it just by substituting into either one of the equations. So I have 2x minus 4 times negative 3 equals 10. This makes 2x plus 12 equals 10. 2x equals negative 2 and x equals negative 1. So my coordinate, the solution, is going to be negative 1, negative 3. We can check this in the original set of equations, making sure that it satisfies both of those equations. So when I want to check, I'll put it into the first equation. 2 times negative 1 minus 4 times negative 3 equals 10. This makes a negative 2 plus 12 equals 10. So we know that the point negative 1, negative 3 is at least a solution to the first equation. We still have to check with the other equation. Negative 5 times negative 1 plus 5 times negative 3 equals negative 10. That's 5 minus 15 equals negative 10. And that works. So the point negative 1, negative 3 is a solution to both equations. It is the place where those lines in 2-space intersect. Now we can try elimination with a 3-variable system. The first thing that we're going to do is identify which variable we want to get rid of. I'm looking at right now equations 1, 2, and 3. I'll keep them labeled like that so that I can keep things straight and keep track of everything. I'm going to look at equations 1 and 2, and I'm looking at the y variable. The reason that catches my eye is that I see that they're already of opposite sign. I can use equation 1, x minus 2y plus 3z equals 7, and I can take 2 times equation 2 and get 4x plus 2y plus 2z equals 8. What I've done is I've given the y variables opposite coefficients, so they're going to cancel each other out when we add the equations. I get 5x plus 5z equals 15. Now, it doesn't seem like we've gotten anywhere, but what we'll do is call this equation 4. I need to do this again and go ahead and eliminate the same variable. So I'm looking at trying to eliminate the variable y in 2 different equations. 1 and 3 would be great candidates for that. We actually don't have to modify those equations at all. The coefficients of y are already opposites. So I'm just going to write them down again here. And then go ahead and add. I'll have a negative 2x, my y's cancel out, plus z equals negative 3. And this I will call equation 5. Now what we want to do is take equation 4 and 5 and pit them against each other so that I can eliminate either x or z. Now, if you look at the x variables, they already have opposite signed coefficients, but I'm going to have to modify both equations to be able to get them to cancel. So what I'll want to do is I'm going to opt to get rid of the z. I can just multiply equation 5 through by a negative 5. So I'll do that here. Equation 4, I'll write down as it is, 5x plus 5z equals 15. And equation 5, I'm going to multiply by a negative 5. So I get a 10x minus 5z equals a positive 15. Now we can add those two equations together and eliminate a variable like we did in the 2 by 2 system. This will give me 15x, my z's cancel, and equals 30. So now x equals 2. All right, we are not finished. Just like before we had to have an x and a y, we're going to have a x, y, and z ordered triple for our solution. Now what we'll do is take that x equals 2 and use it to back substitute. So we're going to take this x equals 2 and we can put it back into either this equation or we can put it into this equation. You want to put it into equation 4 or 5 because those two equations only have two variables. I'm going to opt to put it into equation 5 simply because the numbers are a little smaller. That's the only reason. So equation 5, I'm substituting in negative 2 times 2 plus z equals negative 3. Now, negative 2 times 2, you get negative 4 plus z equals negative 3. So z equals 1. Now I have x and z for my solution. I need to get y. So we'll come back up here to one of the original 3 equations and use our x and our z values so that we can solve for y. I'm going to go ahead and use equation 2 just because it doesn't have negatives. The numbers are fairly small. It just seems to be simpler. So equation 2, 2 times my x of 2 plus y that we're solving for now plus my z of 1 equals 4. So that gives me 4 plus y plus 1 equals 4. If I subtract 4 from both sides and then subtract 1 from both sides, I'll have y equals negative 1. So there's my ordered triple, and that's the solution to that system in 3 variables. Again, if you want to check this, you can put that solution into each of those equations and make sure it's a solution to each of them. Let's solve this system of equations if possible. X minus 3y plus z equals 4 and negative x plus 2y minus 5z equals 3. Those are two good equations to put together to eliminate x. So let's do that here. I don't have to even modify the equations. I'm just going to write them down again, keeping all my work in the same order as before. And now adding those equations, I'm going to have my x's cancel, negative y minus 4z equals 7, and we'll call this equation 4. Now we need to pick two other equations and try and eliminate the same variable. Let's take equations 2 and 3. Equation 3, I don't need to do anything with that. I'll just copy it down. But when I'm looking at equation 2, I'm going to have to multiply it through by 5 so that my coefficients of x are opposites. Plus 10y minus 25z equals 15. Now, when I go ahead and add those equations, my x's eliminate, and I'll have a negative 3y minus 12z equals 23. We'll call this one equation 5. Now I want to use equations 4 and 5 against each other to be able to eliminate another variable. I'm going to keep equation 5 the way that it is. Negative 3y minus 12z equals 23, because that way I can multiply equation 4 just by negative 3, and that will give me an opposite coefficient on the y. So negative 3y, a positive 12z, and a negative 21. Now when I add these equations, my y's cancel out like I was hoping, but my z's also cancel out. So I have 0 on the left side of this equation, and on the right side I have 2. So this is going to be a system that has no solution. Whenever you're solving a system and you get this statement that is a false numerical statement, it means you don't have what you were looking for. In this case, we have no solution. All right, let's practice with this, solving a system with 3 variables. I'm going to label these equations 1, 2, and 3. Now I notice with equation 2, I'm already missing my y variable. It will go straight from an x to a z. So let's see if we can pit 1 and 3 against each other to get rid of the y variable there. What I'll do is I'll just use equation 1 as it is, and with equation 3, if I can multiply it by 3, then that is going to give me an opposite coefficient on my y. There we go. So let's go ahead and add those. I get a negative 7x, my y's cancel out as planned, and a negative 21z, which equals a negative 56. That's equation 4. Now, normally we'd have to do that again and eliminate a variable, but we already see equation 2 is missing variable y already. So I'm going to take my equation 4 that I have, and I'll see if I can eliminate x. I'm going to take 7 times equation 2. That will give me a 7x plus 21z equals 56. And when I add those, my x's go away, but my z's also go away, so I have 0 equals, and on the right side, the constants cancel out. So I have 0 equals 0. Now this is not the false numerical statement that we had before when we ended up with no solution. This, we will have infinitely many solutions. But it's not enough to say that we have infinitely many solutions, because those infinitely many solutions have a particular form. What we'll do is go ahead and define everything based on z. Whatever z is, that's what it is, and then we use that to generate the other answers. So let's go up to equation 2. Equation 2 says that x plus 3z equals 8. And so I know that x is going to be 8 minus 3z. So x is 8 minus 3z. Now we need to figure out what the y is. Equations 1 and 3 are the two equations that have a y in it. So you need to pick one of those and then substitute the x that you have. I have a negative 3 times an x, which we just found out was 8 minus 3z, and then plus y minus 4z equals negative 13. Now let's go ahead and distribute. I have negative 24 plus 9z plus y minus 4z equals negative 13. Now I can solve for y and know what that y is in terms of z. So y is going to be negative 5z. If I add my 9z and my negative 4z, that's a 5z, and I have to subtract that from both sides. And then my negative 24, I'm going to add 24 to both sides, and I get a positive 11. So my y is a negative 5z plus 11, or you could just write it as 11 minus 5z. So this really is your solution, and it's a way for you to generate infinitely many solutions that lie in a particular place in 3 space. Let me show you how this works, just as an example. If z equals 1, then the coordinate is going to be, we put a 1 here, 1 times 3 is 3, 8 minus 3 is 5. We put a 1 here, 1 times 5 is 5, 11 minus 5 is 6, and there we have the z as 1. Another example, and this is, let's say if z equals 0, then this would be 8, 11, 0, and so on. You could let z equal 2, and then x and y would both depend on z being 2. We haven't even touched the negative numbers, decimals, irrational numbers, all kinds of possibilities here. Infinitely many solutions, but they're of this form in terms of z. All right, now let's look at this application of systems of equations. Maricopa's Success Scholarship Fund receives a gift of $130,000. The money is invested in stocks, bonds, and CDs. CDs pay 6% interest, bonds pay 3% interest, and stocks pay 9.4% interest. Maricopa's Success invests $45,000 more in bonds than in CDs. The annual income from the investments is $7,380. Define your variables and create a system of equations to model this investment. Do not solve. We've spent a lot of time solving these systems. You can do that. The really intimidating part of this is to come up with a system based on this word problem. So the first thing that we're instructed to do is to define our variables. We definitely need to do that. So when I have my variables, I might as well make them more descriptive. I can let S equal the amount invested in stocks, and then let's let B equal the amount invested in bonds. Let's let C equal the amount invested in CDs. Now be descriptive when you're defining your variables. Don't say let S equal stocks, let B equal bonds, let C equal CDs. Might be tempting, but you have a couple of different things going on with stocks. You have a couple of different things going on with bonds, a couple of different things going on with CDs. We have amount invested in those stocks, bonds, and CDs. We're also going to have the interest that is earned off of the stocks, bonds, and CDs. So to be abundantly clear when we're putting this problem together, you need to not slack on defining your variables nicely. All right, let's go ahead and read through the problem. It's not unusual to have to read through the problem several times to really gather the information and get it in the right spot. So don't get discouraged, just stick with it. Maricopa Success Scholarship Fund receives a gift of $130,000. So that's the total amount that they have received to invest. And they've invested that in stocks, bonds, and CDs. Well, we can make an equation just from that. We have the amount invested in stocks, which is represented by S. And we add to that the amount that is invested in bonds, represented by B. And we're adding to that the amount invested in CDs, represented by C. If we add up those three amounts, it's going to equal the $130,000 gift that the scholarship fund received. So that's our equation 1. Now we go on to the next bit of information. CDs pay 6% interest, bonds pay 3% interest, and stocks pay 9.4% interest. So the way that you can figure interest is to multiply that percent. You can go ahead and convert it to a decimal form. You're going to multiply that number by the amount invested. So how much are we earning on the CD? We're going to earn 0.06 times however much we invested in the 6% CD account. And then we can add on the bonds. The bonds pay 3%. So here I go with the 0.03. 3% times whatever amount you invested in those bonds. And then we have stocks. The stocks paid 9.4%. So we're going to take 0.094 and multiply that by however much we invest in the stocks. And those amounts together will be the earnings that you have. That information is in the problem as well. It's in here, this sentence. The annual income from the investments is $7,380. So they're telling you in another way of conveying that the interest will add up to $7,380. And we can call that equation 2 if you want. And then we have to have a third equation. If we want a chance of being able to get a solution for this that's a nice, concise, ordered triple, then we need to have 3 equations since we have 3 variables. So the one piece of information we haven't used is this. Maricopa's Success invests $45,000 more in bonds than in CDs. And this bit of information can really kind of turn students around. So you have to really think through this, or maybe formulate another way to say it so that you can put it down as an equation. So they invest $45,000 more in bonds than in CDs. So bonds is the amount that they invest in CDs, but another $45,000. So the amount invested in bonds is the same amount as is invested in CDs, but another $45,000 more. It's just one way you can think of that to get the right equation. And we can call that equation 3. And if you want to go ahead and solve that, you can do that. The first step I would take is to go ahead and rearrange those so everything is in the SBC order that you've defined your variables. Okay, and then S, we've got 0.094S plus 0.03B plus 0.06C equals 7,380. And then on that third equation, I don't have S, but I do have B, and it would have to be a minus C once you get it to the left side of the equals sign, and that's going to be 45,000. And then you can go ahead and solve those using the elimination method that we just did. Now your answer is going to be 45,000 for the stocks, 65,000 for the bonds, and 20,000 for the CDs. If you want to know the answer to that and work towards that just as a practice problem.